than I do, the Secret Service is an important body in the American power structure, since they take over power immediately and automatically if nobody knows where the president or the vice president is. And they also have the power to tell the president and the vice president where to go. And they have to anytime. The Security and Exchange Commission may, to some, be particularly interesting in this connection, because this is a body which takes care of everything regarding fraud and corruption in corporate America. And at that time, they had between 3,000 and 4,000 unsolved cases in these offices. And among them, all of the WorldCom scandal from California and a big deal of the Enron scandal, which all of you are probably very well aware of. On top of this, on the 23rd floor, there was an Office of Emergency Management, which in its own right is very interesting, but we do not have time to go further into that. Now we are going on our timeline 7 hours after the collapse of the North Tower. So now it's 20 minutes past 5 in the afternoon, and this thing happened. It's gone, man. 17 minutes. But this was Building 7. It came down just like that. There are several videos of this event. I'll show you only 3. The next one is taken down West Broadway Street from a distance, where we have to get an impression of how big this building was, not just an ordinary office building. And the next one is taken long distance from Midtown Manhattan, and which is an advantage because there you can see quite clearly the whole profile of the building. And the soundtrack here is Dan rather, unfortunately, is a little weak, but I'll try to crank it up. And if you're quiet, you may hear what he says.
And again, what you're seeing are high shots. Now, here we're going to show you a videotape of the collapse itself. Now we go to videotape the collapse of this building. It's amazing. Amazing, incredible picture word. For the 3rd time today, it's reminiscent of those pictures we've all seen too much on television before. A building was deliberately destroyed by well-placed dynamite to knock it down. And
well, I don't know if you got what he said, but he went into retirement very early after this. These are the facts that he was over. Now, World Trade Center 7 collapsed into a tiny little pile of garbage. What you see here, only about 20 meters, 2 stories high, and what's left is only the steel frame of the building. Also noteworthy here in this picture is that the facades of the other buildings around here are almost untouched. Maybe there's a chunk which has been bitten off this building here, but basically the building fell completely and accurately into its own footprint. And this picture is taken from the south. Again, you see the facade, you see there's a chunk which has been, certainly there's a little damage here, but what remains is only the rest of the steel frame. Everything else is gone. Little nice tiny pile. I put in this picture from the time when everything was still okay, taken from the top of the South Tower to give an impression of the enormity of the fact that this building, this is a car, okay? There's a long way down. And I hope that this whole building is somehow packing itself into its own footprint, that there's not much space to operate on in Lower Manhattan. We call this an implosion, what happened here. And this is the opposite of an explosion. An explosion is when you have a container and the pressure is too high and the containers go all the way. But imagine that you had very strong lungs, that you could suck out all the air from, say, a soda can, and the can would go collapsing into itself. This is this is an implosion, because the inner core of the building went down first, and then the outer panels folded on top of the inner part of the building, ending in this part, this tiny little pile of debris. Let's repeat. Oh. The gauge doesn't like this. So let's see if we can recover. Take it from here.
It's gone, man.
And it went down pretty fast. Okay. So, question is, from the physicist's point of view, how fast actually was this collapse? This phenomenon has been investigated by an American physicist called David Chan. It's a very simple high school actually piece of experiment. He used the video I showed last, the one with Dan Rather, taken from a distance. And then you have a program called Tracker, where you can lock the cursor onto a specific point in the picture. In this case, the northwest corner of the building, this one up here. And since there are 25 frames per second in the video, you have an internal clock which very accurately can time the trajectory of this point when it's going down. And you obtain all these positions when it's going down. From that, you can calculate the velocity of the thing going down. Now I have to teach you a little physics. Because what we are doing here is, or what has been done here, is that the velocity has been plotted as a function of time. Now the curve is going downwards simply because the building is going down. So we have 0 on top, and every position is measured minus meters from this position going down. But the velocity is increasing. It's becoming more and more negative. And there are two very important features of this curve. First of all, it is going into, there's what you call a nick here. Right here, it's resting a little bit, and then suddenly it goes into this perfectly straight line. And when we're plotting the velocity and it's perfectly straight, it's meaning that the velocity is increasing constantly. You have constantly increasing velocity. Now what does this mean? I asked an old fellow from England, and he really knows this. He wrote a book, and actually he wrote it in the 1660s, but it took him a long time to publish because, well, if you know history, Galilei, he got some rough treatment from the Catholic, from the Inquisition, 20 years before that. So he kept it in the drawer for almost 20 years until Halley, the guy with the comet, came along and urged him to publish this book when it finally came out in 1687. And this is the most important book in physics because it describes how bodies move in the real world. And Newton told me that when you have the speed constantly increasing, this is constant acceleration. Every one of you who is driving a car, or even flying an airplane, will know that when you go down the runway, the speed is increasing constantly. This means that you have constant acceleration. Now the number, maybe you noticed, the slope on this straight line in the previous plot was 9.88 meters per second squared. This you don't have to remember. But Newton recognized this acceleration as free fall. Now what is free fall? Well, free fall simply means to somebody something is falling freely. And Newton, from his book in 1687, even provided us with the formula for how you can calculate